All right, hello, and welcome back to school. Um, so, I guess you guys are going to be taking this course online, basically, which is fine. Uh, it'll be different, obviously, than if you took it in person. So, I'm going to have you guys in a separate little Google Classroom and a separate, keep your grades kind of separate because it'll probably be a little bit different in your experience than the other students in the other section. So I just wanted to, since you're not going to be able to be there for the lecture, I just wanted to sort of say some of the things that I would say in the lecture, and I wanted to um, just cover some basic information. Normally, the first lecture, the teacher will, go through, what's the course going to be like, what's expected of you, um, what kind of demands, how demanding will it be, things like that. What kind of assignments, what kind of score breakdown. So we'll go over some of that. Um, and Also the things that are subject to change. So that's one thing I'd like to say right off the bat. We're really going to have to play it by ear this year, and if things don't work, they'll be replaced. And if the situation changes, we will adapt. Uh, in coming up with how this course would work, it was hoped that it'll be much smoother if we have to go home, or if some people have to go home, if some people have to stream while other people are live. Uh, so I've attempted to prepare flexibility into the system, but we'll see how well I prepared because I think we'll probably have some things to have to adapt to as the year goes by. This year is going to be very different for a lot of reasons, but there's a lot of things that aren't going to be too different. So, while I can't tell you exactly how everything will play out right now, um, I think I can give you a good idea of what the course will be like and how demanding it'll be. And, I think what we did last year will be similar to what we do this year. So I'd like to describe that and then talk a little bit about what statistics is. Like what did you just get yourself into? What is this? So I thought we would start with that. In the class with the lecture, the other section, I think a lot of the time this week is going to be eaten up by going over the rules, what are the new procedures, cleaning desks and everything. Um, so I think you guys will probably make a little bit more progress earlier than that section will, because you guys will just kind of just get to work. I got a little bug in here. Uh, okay, so I don't have the syllabus finalized yet. I sort of changed my mind about a few things last minute, and I can't tell you right now exactly how things will play out. I can tell you generally what we'll be doing, and soon I'll have a syllabus for you. The way that grades worked last semester was that basically there was only tests. There were only tests. There was practice assignments. They weren't graded. Uh, I didn't even ask to see them. Students usually showed them to me to make sure they were doing them right because they didn't want to fail the test. But so I saw students' homework because they wanted me to. It wasn't really because I made them do it and I wanted to see it. It's really good to make sure that you do the practices and you stay up on what you need to know so that you don't have to cram before a test. Like just chip away at it every day or every other day or whatever. A nice regular schedule of making progress, making sure that you have the skills to do these problems. But it's going to be a little different this year, just because of just the nature of if we did go back home and to remote learning, how would I monitor the tests? If we're really going to make it smooth so it's the same either way, I don't know. I think we're going to be assigning points to the assignments just to make sure that people are doing them. And if the tests become hard to administer, we may need grades in the grade book other than the tests. So I think those will be worth little points. Nothing major, but definitely eligibility will be tied into it. I don't think that'll affect any of you, though. I think usually the stats and calc courses are, have strong students. So the idea here is that you'll have regular assignments to practice. There'll be tests over major topics, and I'll explain what those topics are in just a second. And that's pretty much, I think, the grades that you'll have. Last year and the years before at Newman, I always liked that Newman takes what is at Sauk a semester-long course, and it stretches it to a full year. So Newman, you have way more time, and your semesters are kind of longer than a Sauk semester anyway. So you kind of get a couple extra weeks each semester, and you get a whole extra semester. So while the course can be kind of a lot packed in all at once at Sauk, it's still doable for a lot of students, and you have a year, so that's good for you. So the way I structure the course is the very first part is pretty easy. Actually, I hope you find it pretty easy. But then we get into probability, which isn't hard. I don't find it hard. Like once you know it, looking back, it's not that hard. But it takes some wrapping your head around, and actually there's when you get into really complicated probability problems, it's confusing for everybody. Everybody can get pretty confused thinking about probability. Our brains don't really think that well in those terms. So when we get into probability, and then when we build on that, which will be the first semester, we'll start sort of in the middle, and that's kind of what we'll probably end the semester with, is probability. That'll be the hardest material of the course. So except for the very beginning stuff, we get to the hardest stuff of the course pretty quickly. At that time, some of you may think this is kind of hard. Some of you may think it's really easy. Some people, actually one of your brothers, I think, said of it that all you got to do is know how to use your calculator. You're just training a calculator monkey too. As long as you're good with the calculator, these problems are easy. And in a way, that's true. But then other students have said, like, I know what buttons to push, and I know it's all done by the calculator pretty much. But I don't know what buttons to push for which problems. So that's sort of the thing about it. You're not going to be doing like problems on paper, multi-step problems. Well, first you got to move, do this manipulation and do this, all this math stuff. Really, I will explain the math that goes into it, but statistics is really best done with technology. All the numbers should be computed by computers. In real life, when you do statistics and you're dealing with millions of pieces of data, I know you know how to average. I know you could add them up and divide by 1,000,000, but no one's ever going to want you to add 1,000,000 numbers. Like, why would you want to do that? So you're always going to use technology to compute things. So computing the results, the numbers, not hard. You're going to use a calculator. If we go to remote learning, you don't even need the calculator. You can just go to the various websites, and they'll do the job of your calculator for you. You don't have to buy a calculator. So it's not hard like other math classes could be hard. it's just tricky, and you just have to think about it. So I hope that helps you understand kind of like the difficulty level. So the way I sort of see the course, it sort of ramps up difficulty kind of quickly. It won't be too bad, and then it just kind of steadily gets easier as you go along. So it ends, I think, normally a pretty. It ends, pretty smoothly, but it can be kind of hard in the first semester for some people. So just know that it'll get easier as you go if you do find you're finding it very hard. So I hope that answers some of your questions. Now, normally at Newman, we would have the fourth quarter. I would sort of not stretch the whole course from one semester to 2 semesters, but from 2 quarters to 3. And then in the fourth quarter, we would do research projects where you guys would go around the school, interview people, measure things about people, or whatever, get data, collect data, and then try to do analysis on that data to say something about the students who go to Newman. That didn't happen last year because the stay-at-home orders took effect pretty much right at fourth quarter. I don't know what it's going to be like this year, so I don't know that we should plan on that kind of a research project at the end. Hopefully things will change. Hopefully you guys will get that experience. I think it's an enriching experience. But at Sauk, they don't do that because they don't have the time. So I really like when you guys get to do your own project, but we'll see. And if that's the case, then we're going to stretch 2 quarters to 4, and I think it'll feel like a pretty easy pace, like a pretty, you'll have twice as long as students at Sauk would have to do everything. So hope that gives you an idea of how this will go. Let me know if you have any questions. I guess the last thing I'd like to talk about is what is statistics? What are you doing here? So usually in class I'll show this picture that you're seeing now, hopefully. Sometimes I call it parameter pond. We'll explain that. Or sometimes statistics C. Whatever you want to call it is fine. But here's a picture. And I usually start by just asking students, let's say a team of researchers wants to know what the average length of a fish is in this body of water. So they hire a fisherman. They paddle out or a few minutes away from the shore. They cast their net for a couple hours, catching fish, marking what they catch, and then releasing them, and then doing it again. And after a couple hours, they go back into shore, and that's their data. And then I ask people, do you think they got good data? Do you think from their data, thinking about the way that they collected it, do you think that they got an accurate representation of all the fish in the sea? And I'll let you look at the picture and kind of think about that for a second. And then I show the next picture. Oops. And then here it is at night, that same spot. So day, night. Hopefully you'll see that if they went out in the day for a couple hours and just cast a net from their boat, that they're missing a lot. That they're not getting a good picture. So we will probably more in the second semester go over how do you make sure that when you collect data, you get a what we call a representative subset of the group that you're trying to study. And so the first thing that we're going to go over is we'll get to how you get good picks, I guess, when you're picking out of a lot like this. But right now, the main concept is that I want to go over is what is statistics and what are you doing, and what's the point of it. So think for a second. If you wanted to know something about all the fish in the sea, like how long they are on average, that's hard because there are so many of them. Now, technically, you could drain the lake and get to them more easily, but they'd all be dead. So it's too invasive. It's too expensive. It's too much work. Nobody can do that on any normal budget. So that's not going to work. So statistics is actually about how can you take a small subset of things that you want to know something about all of them, the whole population. How can you just get a few of them and get a reliable sense of something about all of them? How can you do that? That's what statistics is all about. How can you use, well, it's like what math is always about. How can you take a limited amount of information and figure out the rest? It's not like other math, though. It's not certain. That nothing in statistics is certain. So you'll get things like, oh, I'm 80% certain that this is so, or I'm 60% certain. But that's always what you're going to be dealing with. So statistics will never give you like a guaranteed result because you had limited information. You didn't have all the information. You only had some of it. But it can give you something that's good usually. Like 9 times out of 10, you can trust it. 1 time out of 10, it will fail you. Guaranteed 1 time out of 10, it's going to fail you. That's what 90% certain means. That 9 times is right, 10 times is, or yeah, once is wrong out of 10. So statistics helps you make good bets, but sometimes you can have, the second highest hand in poker and lay it, and somebody has the highest hand. So yeah, it was a smart bet to go all in when you had the second highest hand, because how likely is it that the 2 highest hands would be in the same game? But it can happen, and a certain percentage of the time it will. Should you make that bet? Yes, because most of the time you're going to win. Some of the time you will lose, but if you play a lot, those will average out to be a lot more wins than losses. So that's kind of what statistics can do for you. It's not going to give you answers or it can't tell you, it can't give you a sure thing, but it can help you make smarter bets, if that makes any sense. So the way statistics kind of works is that there's always a population, a group that you want to know something about, the whole lot of them. So in this case, it's all the fish in the sea. It could be all the trees in a particular forest, or all the birds that live in those trees. It could be all the people who live in Sterling. There's some population that you want to study, that you want to know something, aggregate data, like what's the average, or what's the total of all these people's incomes or something. You're not going to get everybody, but you want to get a limited amount of information, and that's called a sample. So like these guys in this boat, the population they want to study is the fish. They catch some, and they use the data from the lengths of the fish that they caught. They average the lengths of the fish that they caught, and they're using that as a stand-in. They're assuming that that's the same as what they would get if they were somehow able to measure the lengths of all the fish They think their samples average is going to be like the population average, where the sample is a small part of the population. So right there are some of the key concepts in statistics that we'll be talking about all the time, and we have key vocabulary for those things. There's the population at large. There's the sample, the some of them, but not all of them, that are selected for study. So you have the population and you have the sample. Well, we found an average length for the population, or we want to imagine that we can find an average length. There is an average length, but we don't know it. It's too hard to figure that out experimentally. But we did calculate an average length for the sample. So we have the population, we have the sample, and each of those has their own average. And the question is, how like the population average is the sample average? Are they similar? Can you use the sample as a sort of microcosm of the population? Those are two different averages. One's the real average for the whole group, and you don't know it. One's the best you can do, average of your sample. They are both summaries of those data sets. They summarize those sets in the same way. You take the average in the same way. It's the same formula for how do you take an average. But we give them different names. Because the average of the whole population is for the whole population, it is called a parameter. And it's something you want to discover. So P goes with P, parameter, population. S goes with S. The sample average is called a statistic. If I found the average weight of the sample, it'd be a statistic too. Whereas if I found the average weight of the population, that would be a parameter too. So statistics are for the sample, and parameters are for the population. But they're both just summarizing the list of numbers. Just one's for the big group and one's for the little group. And the whole question is, how do you make the statistic like the parameter? What can statistics tell you about the thing you really want to know? Parameters. So the science of statistics, you can say, what is statistics? Well, it's a field of study. But when you talk about statistics as averages of small groups or things like that, then you should say, what are statistics? They're numbers, or maybe not numbers, usually numbers, but they can be other things too. And we'll get into that as well. So statistics is all about, as a field, how do you use these numbers, these summaries of lists, these statistics? And how do you use them to have confidence about the range of values that a parameter lies between? And that's what the whole thing is about. So in this, we have a few different parts. The first part is called descriptive statistics. And that's just, how do you take a list of numbers and summarize it? How do you get a feel? So, like, if I just gave you a huge table of numbers, what can you do with that? But if I made a chart, that might help you understand it better. If I found averages, if I told you the range of the numbers, the standard deviation, we'll explain what that is too. Don't worry, that's part of this class. How do you summarize a cloud of data? Like, where's the center of this range of this set of data? How wide is it? How bunched up is it? How spread is it? These are things that we're going to describe with descriptive statistics. Descriptive statistics, that's where we'll start, and that's pretty easy. I think you'll all find that enjoyable. Then we'll get into something else, which is probability. And probability is kind of like, okay, let's say you know let's say I've got a jar of marbles, and I've got 30 red marbles and 50 blue marbles. Well, in this class, you'll learn how to calculate if I reach into the bag and I scramble it up, how likely is it that I'll get all red if I pull out 5, or all blue, or 3 red and a blue, or 2 blues. So probability gives you the ability. So like if you knew what was in the bag, in the jar of marbles, it can tell you the likelihood of pulling something out. It can give you the chances, the probability. Statistics is kind of the opposite. So, well, we had descriptive statistics. Probability is like, okay, if you know what's in the bag, how likely are you to get this draw? That's probability. Then there's what you really care about, which is what people use, what makes statistics useful. And that's called inferential statistics, which just means drawing a conclusion. So to infer means to draw a conclusion. So I infer from your red face that you don't feel so good. So you're drawing a conclusion. So inferential statistics, not descriptive, but inferential, is you kind of have to take descriptive statistics and probability theory, put them together to come up with what we call inferential statistics. It's kind of like probability, where if you know what's in the jar, you can figure out how likely it is to pull out in a specific drawing. But it's the opposite. With inferential statistics, it's if you don't know what's in the jar, can I reach in and pull out a drawing, a handful, and come by that way to know something about the makeup of the jar? So probability, you know what's in there, and you're going to see how likely it is to get all red or all blue. But with inferential statistics, if you don't know what's in there, if I pull out all red, what does that tell me about how what it consists of what's in there? So there's parts of it. It's kind of it's very related to probability, and in fact, we have to use probability to be able to do inferential statistics. So in this class, the whole first semester, we're not even going to probably get much to inferential statistics. I think we will a little bit, but mostly we're going to be working on descriptive statistics and probability theory. Anyway, I hope that makes sense. I've got some stuff for you guys to do, but I think the other class, we'll sort of draw that out, and I think you guys might just move through it pretty quickly. So I think I'm going to give you guys that next class. So for this class, just, I guess, watch this video. I will post something for you to read. I'll keep it short. And then, so just, you can watch this, read. It has some vocab, so try to make sure that vocab makes sense to you. And then email me any questions, and then I will have a sort of I'll have more things for you on, what's the next day? Friday. All right. I hope this goes well. I wish I could see you guys more, but I'll see you a little bit, so that's better than nothing. All right. You guys have a great day, and I will talk to you later.